colloid or a colloidal dispersion is different than a solution. So here, this is a mixture, but we have a substance that's dispersed into a dispersing medium. So we don't have a solute and a solvent. And what's different about this is that the particles are larger than the particles in a solute, in a solution. So these particles, they're still small enough to stay suspended in the liquid, but they're larger than normal solvent particles. And so what we see is that oftentimes colloids are opaque. They're not clear. You can't just see through them. And that's because those particles are large enough that they interfere with light passing through the solution or the colloid. So those particles are typically a nanometer to 1,000 nanometers in diameter, which is a lot bigger than water molecules. Under a microscope, colloidal particles have a distinctive jittery motion called Brownian motion, and that's caused by collisions with molecules in the liquid. And this is the same video we watched earlier, so we're just going to skip that. But the colloidal particles are large enough that you can see with a microscope, and we see them jumping around because they're being hit by the water molecules, which are too small to see. When you add soap to water, the soap molecules can form what are called micelles. They form these little balls. Remember, this is an example of a soap molecule. So the one end is polar, has an ionic head, and then we have this long hydrocarbon tail that's nonpolar. And so these guys, they're like two creatures in one, right? And so they'll form these balls kind of circling the wagons, and they'll have all of their nonpolar tails in the middle, and they'll put their polar heads outside where the water is. Because the nonpolar tails don't like the water, and the water doesn't like them. And so these little spheres of soap will form, and they will be, they'll stay separate from each other because of the charges on here, these like charges, and so they're going to repel each other. But these then are much larger particles, and so if you have a soapy solution, it's going to be a little bit cloudy, right? Proteins can also form colloids. There's a lot of different types of colloidal dispersions. Gas dispersed in a liquid is one of my favorites. Whipped cream, right? Air bubbles in butterfat. So all of these are examples of colloids. Fog, familiar with that. We're also familiar with smoke. And we can't see through the air as well because those particles are large enough that they are going to block the light. And then we have the Tyndall effect. So if a colloidal dispersion is rather dilute, it may look clear, but if you pass a beam of light through it, you're going to see where the beam of light goes. And that's because those particles are larger and they're going to diffract or deflect the light. Whereas this is a solution and you can't see where the light is going through that. So if you've ever seen, say in your house where you got sun streaming in the windows and it's like, oh, there's sunbeams. That's because you haven't been doing a very good job keeping your house clean, right? What causes that is dust in the air. And the dust particles are large enough that they're going to scatter the light, and that's what causes sunbeams.